If you're running any kind of modern tech stack, you've almost certainly felt this pain. Your observability bill is just skyrocketing. But here's the crazy part. At the very same time, you're being forced to throw away most of your data just to keep those costs from completely spiraling out of control. So how is it even possible to pay more and more for less and less visibility?
This really is the million-dollar question, isn't it? It's what keeps engineering leaders up at night. You're paying a huge premium for these supposedly powerful platforms, but then you're forced into this thing called data rationing, aggressively cutting like 99% of your operational data. It just feels completely broken, probably because it is.
All right, so where is all that money actually going? Because I'll tell you, it's not what you think. We're about to pull back the curtain and uncover this sort of hidden surcharge that's at the very heart of this broken economic model.
To really get what's going on, you have to follow the money. So let's do that. Let's take just 1 gigabyte of log data and see what it actually costs to handle it, from just storing it to actually making it useful.
Okay, first up, simple storage. If you just want to stick that gigabyte in a super durable, highly available cloud service, say something like Amazon S3, it costs you just over 2 cents. For a whole month, I mean, that is ridiculously cheap. Data storage is basically a commodity at this point.
Now hold on, because here's the shocker. What's the cost to send that exact same gigabytes to a traditional observability platform and, this is the key part, make it searchable through a process called indexing? $5.10. The difference is just staggering.
Let that number sink in for a second. It is 221 times more expensive to make your data searchable than it is to just store it. This isn't some small premium we're talking about. It's a massive, hidden indexing tax that vendors are charging for the really intense compute work of building that search index.
And look, this isn't just about the money. As the source material points out so well, this punitive cost model forces your teams to make terrible decisions, like actively throwing away the very data they need to understand and fix your systems. You're paying a tax that forces you to fly blind.
So how does this hidden tax actually cause problems in the real world? Well, it creates this destructive, vicious cycle that traps engineering teams, and it leads directly to more outages and much slower fixes.
Here's how it plays out. It all starts with those super high indexing costs. That forces you to sample your data. You know, chucking 90, 95, 99% of it just to keep the budget under control. But then an incident hits. And of course, the crucial logs you desperately need are gone. You have zero context. This leads directly to slower resolution times, and it totally burns out your best engineers, who are stuck trying to solve mysteries with no clues.
So this isn't just some abstract technical problem. It has severe business consequences. Your engineers are literally flying blind during critical outages. Your security team, well, they can't spot threats hiding in all that data you just discarded. Any fancy AI ops initiatives you're trying to launch are starved of good data, so they just fail. And the one metric that really matters in operations, mean time to resolution, it just gets longer and longer.
Okay, but what if we could break this cycle? The solution isn't to get a little bit better at sampling data. It's a fundamental architectural shift that gets rid of the indexing tax altogether. It's about moving away from all these disconnected logs and toward connected context.
The core idea here is to completely change the basic unit of observability. So instead of a single lonely log line, the new unit is what's called a session graph. Just think of it like the complete story of one transaction, from the moment a user clicks something, all the way through your complex web of microservices, and all the way back. Every single event is captured, and, this is the magic part, its relationship to every other event is recorded right from the start.
And this, right here, perfectly illustrates how your daily workflow changes. The old way is this painful scavenger hunt, right? You search for an error, you copy a trace ID, you pivot to another tool, you try to manually piece everything together in your head. The new way is more like an exploration. You find the one bad session, and then you just traverse the graph. You move from the error upstream to see what caused it, then downstream to see what it impacted. All inside one single, self-contained record.
Now, this architectural shift doesn't just make debugging way easier, it completely flips the economic model on its head. It actually makes it affordable to capture 100% of your data.
So let's look at a total cost of ownership analysis. Let's say you've got a pretty big application, generating about 1 terabyte of data per day. With a traditional index-centric model, you are looking at a staggering annual cost of almost $2 million. And get this, $1.8 million of that is just the indexing tax. Now, the new context-based model, about $132,000 a year.
I mean, seeing it as a bar chart really makes the difference hit home.
This isn't some small incremental improvement. It's a total game changer. It's an order of magnitude reduction in cost that just fundamentally rewrites the entire economics of observability.
Just think about that for a second. You get to reduce your observability spend by over 90%, and at the same time, you go from capturing maybe 1% of your data to capturing 100% of it. You pay way, way less for complete visibility. It's wild.
So this brings us to what might be the most important question of all. Because this isn't just a technical decision or a financial one, it's really a strategic choice about how you fundamentally view your own data.
See, when you capture 100% of your data, you get so much more than just cost savings. Debugging becomes deterministic. The answer is always in there. You just have to go find it. You can finally unlock the real promise of AI ops by training your models on complete, perfect data. You create this future-proof asset, right? All your historical data is there, ready for new kinds of analysis down the road. And all the while, you're eliminating those huge security and compliance risks that come from sampling.
So, I'll just leave you with this one question. The old model, the one that's broken, forces you to treat your data like a toxic liability, something you have to constantly minimize and manage and get rid of. But a new architecture makes it possible to treat that exact same data as your single, most valuable strategic asset. And the choice you make between those two views is going to define your ability to build and operate reliable systems long into the future.